Hello, everyone, and welcome to the final topic in ITT610, IT development and cloud computing. Our final topic is cloud application deployment, and this is going to be another lab. So make sure you read through all the instructions and take your time. You all have 2 weeks to finish this lab, and it will use the same multi-node or two-node cloud environment that you created in topic 3. All right, so our topic or our reading, make sure you read through chapter 9. It talks about deployment, etc. in a cloud environment, and there's once again a ton of resources available, including some Kubernetes and Docker resources that you can reference. That'll definitely help you. I also do want to mention, if you know what a Raspberry Pi is, you can build a cloud infrastructure using a Raspberry Pi cluster. So if you get a chance, make sure you read through this article. It's very, very important. I know that purchasing Pis, they're a little bit costly, but they're very useful in understanding a cloud scenario. All right, so our objectives for this topic, creating an application deployment in that Kubernetes cluster that we already have, and then demonstrate how a deployed application can be exposed publicly, scaled, and updated. Basically, there can be some exposure, and how you can scale it, scale it up or down, and how it can be updated. And that's very, very important in a cloud environment. So we do have an additional document using Kubernetes cluster to create application deployment, and we're going to go to that document, and it looks like this. That's in resources. Once again, it does have a list of detailed instructions. You simply have to walk through it. And basically, if you need to review your cluster from lab 1, make sure you do that. So basically, we're going to make sure we have the components of your cluster operational. So I will ask you to open up a terminal and run the Kubernetes or the KUBCTL version, and then get nodes. This will essentially tell you what the available nodes are, and you should see your two nodes or your Ubuntu servers that are available to actually build your application from. All right, so we're going to use Kubernetes to essentially deploy a basic cloud application. Now, you should all be aware that when you're looking at a cloud application, it's just like any other regular application, but it's being deployed through a nodal reference. Basically, you have a server and you have a client. You can even think of it that way. So basically, there are commands, and this actually runs through the bootcamp information that's available on Google. It's an application that's readily available. You should be able to access this, and it's like a real application. So go ahead and run that command, and this should pull in from the repository on Google the application that you can essentially render in your nodal situation or scenario. So to get to the list of deployments, you basically run, and remember you're running a Linux, this kubectl get deployments. And you should see that there's one deployment running, a single instance of the app. An instance is running inside Docker. Remember, you are running Docker as a container on the node. And yes, you are running this right now. I didn't mention this, but you should be running this on your master node. All right, because it's essentially you're building an application that can be accessible. So you should see that there's one. Yeah, I just said that already. Sorry. So as far as the pods are running inside Kubernetes. We experienced that during the first lab. So when you run the kubectl, you're interacting through an API. And basically, this is just an endpoint interface between the nodes using Kubernetes and Docker as well. So if you need to review what Docker as a container is, basically it contains the environment that you can access from node to node. All right, so you want to make sure that that's running in your node in a terminal, And then I'm going to ask you, or we're going to ask you to open up a second terminal and run. Essentially, you're going to run this command to check your proxy, and it's just going to echo essentially the information about your proxy. And this is a Kubernetes proxy, so go ahead and run these two commands, and it should give you your proxy information. So you should now have created a connection between the host and the online terminal, so both terminals and the Kubernetes cluster. So the proxy enables the direct access via the API with these terminals. So you're actually looking at kind of a pseudo cloud environment. And to check, or essentially you can now see all the hosts if you run a curl command. Basically, it's a local host. And remember, this is just an internal environment. So you're just using this curl command to take a look at the APIs that are running. And once again, it appears that I'm going through these quite rapidly. Please take your time, make sure that you have, the actual connections, your cluster is actually active. And then all of these commands should make sense. So with this whole two terminal scenario, you can check the first terminal to make sure the proxy is providing that connection. And basically in Linux, you can have the two terminals in a tab and just switch back and forth, or you can have them on the desktop, et cetera. It really depends upon your comfort there. So as you saw here, there's a specific port that we're observing, that's port 8001. So, and if port 8001 is not accessible, it probably should be, but if there's some reason it's not, then you have to go back to ensure that your proxy is running, because that's tied to the proxy completely. So make sure all of that is running correctly, and your pod is actually active, and it's able to support your cloud application as we begin to develop it. All right, so going back to the pod, we do need to give the pod a name. So in here, I'm just using pod underscore name, but you can name it whatever you'd like. And then basically run the commands here to make sure you're developing the environment for that pod within your nodes. You can also access the pod through the API that's running. So if you run another curl command using that port, you should be able to access the pod that way as well. All right. So essentially, what you've just performed in enabling that application as far as a cloud experience. So the next thing you need to do is expose that cloud application publicly. So basically, if you're running a host or a client, you can access that cloud, the cloud application itself. So in this section of the lab, we're going to use the Kubernetes application outside the cluster using the kubectl command, expose command. And you also learn how to view the apply the aptly labels to objects, with this particular command, the label command. But first, we have to verify the application is actually running. And hopefully you remember this kubectl get pods. This will actually tie into the application itself because it's contained in this Kubernetes pod. And you can actually see a result of this running of the app. Well, you'll see the pods. And then to actually see the services, we're going to, essentially run a different command. But if no pods are running, that means that the interactive environment is still reloading. And sometimes this will take in a virtual environment, so it may take several minutes. Usually not, it's usually a few seconds, but if it doesn't start, if it doesn't show a status of running, just try to go through that whole recognition of the pods again. And you can continue once you see the pods running. So don't try to move forward until there's a recognition that the pods are actually running. Make sure that's happening. And then you can go through the kubectl get services again. And then you can actually create a new service. And we're talking about actually tying into that application to expose it to external traffic using the proxy, et cetera. So the command to do that, basically you use an expose command with node port, another command that you'll learn about. And this is the command that you run, or you would run there, wait until that completes, and then run a get services again. So we should now have a running service called Kubernetes Bootcamp. Remember, the bootcamp came from the Google repository, and it shouldn't be anything that would complicate the scenario. And you can see that the service receive is a unique cluster IP, an internal port, an external IP, and the IP of the node, or which is the IP of the node. So you can, yeah, basically, if you see all that information, you know that node port option is running, and you can proceed to the next step and actually essentially describing this particular application, and the Kubernetes command is describe services Kubernetes Bootcamp. And then, excuse me, what we want to do is create an environment variable called node port that has the value of that node port that we assigned earlier. So we're just going to run an export node port, and then that particular information about the port, and then we're going to echo node port, and then that variable node port. You should be able to see that as a running scenario within the bootcamp application. So now you can, after you've done all that, now you can test the app, test if the app is exposed outside the cluster using another curl command. And these commands are coming from the Kubernetes itself. So don't worry too much that this is a credible source. So let me just close these comments here. So make sure you're following these commands sequentially, and you should not have an issue with whether they're running or not. So, all right, let me continue. So we run this curl command on minikube IP, and then your node port. So a response from the server indicates the server is exposed, meaning that it's now publicly you have your actual cloud service running. So to check that, and using the labels, the deployment created a label automatically for your pod, so you can actually run a kubectl command to describe that deployment, and basically it should tie right into the pod of the application. And then you can also use this label to query your list of pods. So basically, we know the pod is tied to that bootcamp application. So run this associated command, and then you can do the same to list the existing services. So it's another kubectl get services command, and then you can get the name of the pod and store it in the pod name environment variable. So the command to do that is right there. Remember, it's essentially run the commands exactly the way they're listed, and then you can echo essentially what that pod name is. And then you can apply the new label by running essentially this kubectl, the Kubernetes command, where you're labeling the pod, and version v1 it's our first version. So this will apply a new label to the pod. You pin to the application version, and you can check it with another describe. And once again, it'll give you a description of the pod name. The label is now attached to your pod, and you can query the list of pods using the new label. And essentially the command is get pods with the version 1. All right, so that should essentially create the application environment for you. Please go back if you're having issues with that. Go back to some of the pod enabling commands, and make sure you're running that bootcamp command or application scenario from Google. So we are going to ask you, if you get to this point, there's such a thing as scaling, and scaling is applicable because generally when you produce or when you create or develop a cloud application, more than likely you'll be asked to, after deployment, you'll be asked to scale out the deployment, and ensures that the pod is created and scheduled to nodes with available sources. So So scaling will increase the number of pods to the new desired state. And so to list your deployments, you want to first do a git deployments, running that Kubernetes command. And then scaling is pretty straightforward. It's just scale deployments. And we're going to scale that application. And we're actually going to add the number of instances to 4. And then you can, list or get your deployments again. So basically we're going from 1 to 4. So we're scaling out so we have 4 instances. That's the whole idea here. Here, the change was applied and there are now 4 instances as I just stated. Next, check if the number of pods change. So you run this command here, your git pods, and you would see there are going to be, instead of 1 pod, there will be 4 instances of the same pod. The change will register in the deployment log events. To check that, you can actually run a command to check the deployments. So now you're actually looking at the number of instances as far as deployments. You can also view the output of this command that there are 4 replicas now. And that's basically what we did. We just scaled it up from 1 to 4 instances. And generally, if you do something like that, then you know that the availability will be there as far as your cloud application. And that's the whole purpose of performing a scaling. And that's essentially how scaling is performed in a cloud environment. If you study one of the cloud platforms like Azure or AWS, you'll see that particular scenario. All right, so I'm also going to walk through updating. There's always updating and patching, etc. Users expect applications to be available all the time. That's one of the parameters here. And developers are expected to deploy new versions of them several times a day. And yes, it may not be daily, but usually a developer will deploy several times. So in Kubernetes, this is done with rolling updates. Kubernetes is actually a very good platform to perform this. So once again, to list your deployments, you can run the git deployments command. And to list your pods, and now you should have 4. Remember, you can run your git pods command, and to view the current image versions of the app, run the describe pods command, and look for the image field. And to update the image of the application to version 2, so remember we were in version 1. Basically, you're going to run a set image deployment, which is simulating essentially an update. We're going from version 1 to version 2. So we're just setting it to the new version of the application. So the command notified the deployment to use different images for the app. Essentially creating or initiating a rolling update. So then you can check the status again, and you'll see that your git pods have changed. But first, you want to check the app to make sure the app is running, obviously. So find your exposed IP and port. And then basically when you want to describe your bootcamp again, create an environment variable called node port. We want to make sure that we can access the application with the upgraded application the same as we accessed it before, and then echo that within your terminal, etc. And then run your curl command for that new node port. So every time you run the curl command, you will hit a different pod. Remember, you have 4 of them now. Notice that all pods are running the latest version. You'll see that they're not V1 now, they're V2. And you can confirm this with a rollout status deployment for that application. And that is the command there. And then you can once again, view and describe the pods and the images. So in the image field of the output, verify you are running the latest image, perform another update and deploy image tag with. So basically what you want to do here is emulate what you just did before, but now we're going to update it to version 10. So you just run through the same process, the same commands. If for some reason you have an issue, you may notice that some of the pods have a status of image pulled back off. If you look in the status to get more insight into this problem, run to describe. It'll give you an idea of what's going on. In the event section, and this may not happen, so you may not have to run through this, but be cognizant of this part of doing an update. So in the event section of the output of the affected pod, notice that the V10 image version did not exist in the repository. And this is kind of a test for you to make sure that you have the correct image for the correct version. So in this instance, you can actually roll back to the version 2. So use it, roll out undo deployments. So it should roll your pods back to version 2, and then you can check that by performing a get pods and describe pods. So the whole idea of this last section, it's not actually something that you have to, if you're having issues, don't let this trip you up. I'm just providing a section where if you don't have the appropriate image, basically you can't run the update. So that particular image has to be a part of what's available. And essentially, if you need to roll back or anything like that, and that's pretty indicative of a cloud scenario, you would want to do that. All right, so this is another, pretty involved lab. Don't let it bother you too much. Just, hopefully your nodes are running fine, your Kubernetes and Docker are in place. If you need to review any of that, I would definitely go back to lab 1 and ensure that your nodes are running to the point that you need them to run. And then once again, this lab is 2 weeks. So take your time. And if you have any questions or concerns about it, make sure to contact your instructor. All right. So that's it as far as what's required for ITT610. It's a relatively involved course. I mean, I do, or we do expect that you can get through all of the topics without any issues, including the labs. The labs are actually more common than you think. And I definitely recommend doing the readings, because that will help you understand. And there's a lot of resources like Kubernetes and Docker and all of that. If you need help with virtualization, make sure you ask. Remember, this is using an Ubuntu, 2 Ubuntu servers as nodes as far as your cloud environment. And basically, after you finish this course, you should understand what a cloud infrastructure looks like. So thank you for listening to the video, and good luck in class. And hopefully you move on to the next class in the project. And believe it or not, you're getting close to the finish. So thank you.